Before we have identified a zone of low shear strength and displayed it in 3D, we will now estimate the volume of the zone, which is obviously important in many practical applications of geoscience. We will first see how we can try to calculate the volume using QGIS. I will need to use raster grids representing the top and base of the layer to estimate the thickness or height of each cell using raster calculator. To convert the height of each cell into CSV format, I drape the grid of points onto the raster with each point representing the middle of each cell. Then I will also extract z-values for the point set to include the attribute of the layer thickness. Next, we can use spreadsheet to import the data and multiply the height of each cell by its surface area. With cell dimensions of 20 by 20, the volume of the layer is slightly above 40 million cubic meters. Now we will look at volume estimation methods in Paraview, which is very simple. All we need to do is to apply the filter integrate variables, which calculates the sum of all values within the dataset. Because the coordinate system of the data we uploaded is represented in meters, the results are also given in cubic meters. As we can see, the total volume of this dataset is almost 50 million cubic meters. When we need to divide the layer we are estimating into smaller parts, for example to exclude certain areas of mineral deposits, we can use resample to image option and display the layer as cells or voxels. Next we can use one of the filters to exclude certain cells based on a certain property. We can control the number of voxels by specifying the property of sampling dimensions, which determines how many samples are taken along each axis. When we increase it, the layer is divided into a greater number of cells, leading to more accurate results. As we could expect, with lower resolution it is easier to manipulate out model, at the cost of accuracy of the estimate, which is still much better than that we have achieved with QGIS. We will use the options we explored in this episode and other more complex aspects of geological modeling. I hope you have enjoyed this video. Thank you and see you again.